Hello again, Adam Wagman from Arduino from Zero, and I thought today we would learn some C++ coding. Um, I'm not going to assume that you know anything about C++ or the Arduino programming language, uh, but we're not just going to learn some of the basic commands. We're going to learn really some good style and a way to write a better and more maintainable program. And one of the more interesting things is we'll learn a little bit about something called event-driven programming, which is the sort of thing that you're really going to need to do once you start programming things like robots, for example, that need to be able to respond to events quickly. And to teach all this, we're just going to use the very humble blinking an LED sample, which is pretty much the first thing almost anyone does when they're programming an Arduino. So all you're going to need for this is two LEDs, two resistors. Almost any value will work. I'm using the 220 ohm ones. And we've got this very simple circuit here. I'll show you how to put it together, and I'll show you how to grab the example code from GitHub in case you want to be following along at home. So let's just see where to get the code from first. So if you go to github.com/Arduino from zero/BlinkLED, you'll get to a screen like this. And the file we're really going to be interested in is this BlinkLED sketches.zip. It contains 5 versions of this program that are going to show sort of increasingly better ways to write code. So we'll go to this code button and say download the zip file. I'll show it on Windows here. On a Chromebook, it's pretty similar. So we'll open this up. I'll just go here and extract it all. You're not seeing this just yet. Hang on. Okay, so now we have File Explorer open. We're just going to open this thing up, extract all of it. There's some other stuff in here, like a picture of a schematic of the circuit, but the one we're going to want is here. So now we will just go back to our browser, and we will go to the Arduino code editor. So that's at create.arduino.cc/editor, and then you will log in. And in here, you would go to import. You'll go to your downloads. Oops. You'll see if you click on that top zip, you'll get an error. So instead, we need to make sure that we go into the BlinkLED sketches that we unzipped. Click the wrong one there. And we just click that one. And you'll see that there are 5 versions of BlinkLED, V1 through V5. And those would actually be these down here. So let's just take a quick look at downloading the code on a Chromebook. It's pretty much the same thing. We go to GitHub, click on the code, download the zip. Show up over here, we'll click on Show in Folders. Get this BlinkLED main. We'll drag that over to my files. And drill down into it a bit. And drag out that LED sketches part. That's the one we're going to want. Now we can go to the editor, import the sketch, go to my file, select the one that's the sketches, And it may say that there's an error, but it actually works just fine. Although maybe a little slow to load. So let's take a look at the first one, but first we're going to show the circuit we're going to build. So we can close this here. Again, whenever you're using these LEDs, there are a couple of things to keep in mind. One is that the LED definitely has a positive lead and a negative lead, and if you plug them in backwards, you will blow out the LED. So the longer terminal of the LED is the positive one. For the resistors, it doesn't matter. There is no backwards. And what I've done here, and I can also call up the circuit diagram that we've got, created by this handy little program called Fritzing. So what you can see here is connected to pin 2. I've got one end of a resistor that goes to the positive end of the LED. The LED goes into this ground rail, and that ground is going to be connected to ground on the Arduino. And we're going to do the same thing for the other LED on pin 3, go into the resistor, to the positive end of the LED, the ground rail, and finally 5 volts connected here. Don't forget to use those resistors, otherwise even if you put in the LED correctly, you will again burn up the LED, this time because there's too much current going through it. And I always recommend wiring up your circuit before you actually plug in your Arduino, just to give you a chance to double check the circuit. Okay, so now let's start looking at the code. And first I'm going to show you the traditional Blink program with a few extra comments. This first version just blinks one LED. We've just got some comments up here describing the program. We're going to pound define a constant, so wherever the program has this pin LED, it's exactly as though you typed in the number 2 with cut and paste and replace everywhere. And I'm also going to have a blink period of 200 milliseconds, just defined another constant there. And I'm defining these constants so that if I wanted to change the pin, I just have to change it in this one place in the program. Same for the blink period. So every Arduino program has a setup function and a loop function. Setup always runs once when the program first turns on. That's when you power on the board or if you reset it. And so the first thing we're going to do here is we're using pin mode, which is a special Arduino function that's going to take that pin LED, which in our case is pin 2, and make it an output. And that just means we're going to write values to it to be able to turn on and off our LED. And then here in this loop function, this keeps running over and over forever at very high speed on the Arduino. And I'm writing comments here. This time I'm writing them with the // C++ style comment. Every line that begins with that is just a comment, doesn't count. And so I'm using the Arduino's digital write to set this pin LED to the high voltage, which is typically plus 5 volts on an Arduino. And then I'm going to delay for half the blink period so the LED is going to stay on. And then I'm going to use digital write to turn it off. And again, I'm going to delay for half the blink period. So if we just run this quickly, let's make it so that we can see everything here. If I download this sketch, or upload this sketch, you'll see it's loading. And lo and behold, the red LED, which is connected to pin 2, is now blinking furiously. So a couple of things to notice. And again, I've added some comments here so anyone reading the program knows what is going on. If you skipped this delay, I mean, you think like, hey, I turned it on, I delayed, I turned it off, good to go. Remember, this loop function is running continuously. So what would happen if I didn't have the delay here would be I'd turn it on, I'd delay for 100 milliseconds, I'd turn it off, it would be off for a tiny fraction of a second without this delay, and it would turn itself back on again. And so pretty much it would just look like it was always on. Okay, so this is a pretty simple program, and this seems maybe initially like a reasonable way to write it. But if you think about it, there are some difficulties here in terms of if somebody else is reading this program, they may have trouble understanding it unless they really know exactly what this digital write does, and maybe the delay. And also, if you start thinking about, well, how do I make two LEDs blink? Are you going to start cutting and pasting all of this code with pin LED and pin LED 1 and a different delay? And things become pretty hard to understand. So why don't we see a better way to write this program? We're going to go to version 2 here. And again, some comments about we're going to make this more maintainable. So we see here we're still using the same pound defines about which LED we're going to use and how we're going to blink it. But now we're going to write functions with sort of more meaningful names that tell us the real purpose of the function, which is that we're going to have a function that'll set up the LED, one to turn it on, and one to turn it off, and we'll even write a function that says make it blink. So that seems like it's going to be a lot easier to understand. So the inside code that we're really wrapping up is exactly the same. So our LED setup function is really just the same as the pin mode output, but now maybe it's a little clearer as to what that's doing. Same for LED turn on, and you'll notice I still have all the same comments, even though the function name is clearer. You still want someone who's trying to dive into this code to understand what's going on. And when I say someone, I also mean it could be you a few months from now after you've forgotten what it was you were doing in the beginning. So turning it on writes a high value, turning it off writes a low value. Nothing new here. And now we'll sort of wrap up that whole turn it on, delay, turn it off, delay into just a one function called blink once. So those are all sort of helper functions we've written, and now we get to the main part of our program. And if you think about it, maybe somebody else reading the code is mostly going to look at what does setup and loop do, rather than looking at all those details. And lo and behold, setup is just going to call LED setup. That's pretty easy to understand. And for loop, it's just going to call blink once. And since loop keeps running forever, it will just keep blinking. So that makes the program a whole lot easier to understand. Now, it's still a little hard to see what we're going to do if we want to blink multiple LEDs or anything like that. I mean, would you cut and paste this LED turn on and have an LED 1 turn on, LED 2 turn on, and same for turn off and blink and setup? You'd basically be making whole copies of these functions here. That's a pretty bad way to go. As a matter of fact, whenever you're programming, if you're finding that you're cutting and pasting code, especially more than once, you're almost certainly going down the wrong path and you're creating a big headache for yourself, especially if, for example, you realized you had a bug somewhere and now you've got to go back and fix it in all the copies. Oh, and let's go ahead and run version 2 and verify that it's going to do the same thing. You can see it uploaded. Yep, no visible difference. Same program, not very exciting, but better. And that's one of the interesting things about programming. Sometimes you can make a program better, and it's better for maintainability and fixing things up, even though it does exactly the same thing it used to do. Okay, so now what we're going to do is make this work for two LEDs. Not very exciting. So, okay, we're going to have it defined for each of our LEDs so that we know one's going into pin 2, one's going to pin 3. We'll give them two different blink periods so that we can actually tell the difference between them. So now our functions are going to take an argument, and in this case they're just going to take an integer called an int, which is going to be the pin number. And so now this one function, if you give it a different value for a pin, is going to be operating on the other LED. So now we can have one function that can deal with whatever LED we want to do. And it's the exact same thing for LED turn on. So remember, we used to have the constant we defined of pin underscore LED, and so there was only one place in the program to change it. Now we're handing an argument to the function so that we can call it with a different pin whenever we want to. Done the exact same thing for blink once. And now we're going to start to see the problem with why this whole concept doesn't even work for blink once. So I've got two versions of this code here, and we'll be able to switch between them by either commenting this out or putting that in. For now, we'll leave it out. So this one says, so we've seen pound define before. Now here we have one that's if in def, which means if not defined. So this thing hasn't been defined anywhere if this thing is commented out. So this is the version we're going to use. So what do? We're going to set up both LEDs. We're using the one function with just the two different arguments. And just to be sure everything starts out off, we'll go ahead and explicitly turn them off. And now we'll look at the loop. And we're just going to call blink once for each thing, and with its own pin value and its own period, either LED 1 or 2, which we might remember is 200 and 400. And let's actually see what that does if we run that. Here we're uploading to the board, and lo and behold, they're both blinking. But if you notice, the blinking looks a little bit weird. You sort of thought that the red one would still be blinking at the same rate we told it to before, that pretty fast 200 millisecond period, and blue would be slower, and each would be on for half the time. This is clearly looking weird. If we go into it, if we think about this in detail, you know, what's really going on? And I've sort of written this up in the code, but I'll just talk you through it. Really what's going on, if you think about it, is, well, blink once says turn it on, delay, turn it off, delay. Now remember, at the end of that, LED 1 is still off. And then we're going to call blink once on LED 2. So we're turning on LED 2 while LED 1 is still off, and eventually turning on LED 2 and turning it off. But so LED 1 has been off this whole time. We've done this blink for LED 2. So, and then it finally turns back on. Now remember, when we're turning this on, LED 2 is off. So what's really happening is we've got sort of a total period that's the time for both of these things. And each one's only on for a smaller fraction of the time. And if you really want to step through it, I've sort of written up when each thing turns on and off, and it's pretty painful. So let's just try to step back and think for a minute about why that's broken. So now we're going not just C++ programming, we're really just thinking about the actual program we're writing. And part of the problem, maybe the main problem, is this delay function. When an Arduino is running, there is only one program running on the whole thing. This isn't like Windows or Mac or Chromebook where you have lots of programs running and they can all do things at the same time. An Arduino is running one program, and when you say delay, you are pausing the whole Arduino. It is doing nothing else during that delay. So imagine if you were riding a robot, it's not looking at its sensors, it's not telling whether it's crashed. And for this LED, it's not doing anything with the other LED. So the whole system grinds to a halt until this thing is done. So that's not really going to let you deal with two LEDs that are supposed to be blinking independently. So now we need to get to something a little more complicated in order to make this work. And what we're going to have to do is get rid of that whole concept of a delay and really just rely on the fact that loop is running all the time, and we're actually going to check how long the program has been running and decide whether to turn on or off each LED. And to do this, we're going to have to keep track of each LED's state. And in this case, what that means is we're going to keep track of whether an LED is on or off, and we're going to use a Boolean type. This is something that is either true or false. And we're going to keep track of the last time we switched the LED between on and off. And we're going to use this weird looking type called an unsigned long. A long is really just an integer. On an Arduino, a long can hold a much bigger value than an int on an Arduino. So in C++, int and long can be different sizes depending on the kind of system you're running on. It might be different for my 32-bit PC than a 64-bit, but an Arduino, an int can only hold a value between minus 32,768 and plus 32,767, whereas a long can go between plus and minus 2 billion, more or less, which in milliseconds is enough for about 50 days. I don't think you're going to run this program that long. And this modifier unsigned means actually instead of plus and minus 2 billion, we're going to go from 0 to 4 billion. And we use this because the Arduino function that measures the time, called millis for milliseconds, that reports how many milliseconds the program has been running for since you turned on the board. That function is defined in the Arduino programming language to return this unsigned long type. Okay, so we're going to do that. So now let's look at our setup function. We're going to set up both LEDs. Again, that's just going to set the pin mode. We're going to turn them off to make sure they're off, just to be explicit. Now we're going to get the current time with this millis function, and we're going to say, we're just going to store in the variables that this is the last time, right now is when we last toggled them, and they're both currently off. And now let's look at loop. What loop is going to do is we're going to get the current time each time we get into loop, and we're going to say, how long has it been since I last toggled each of those LEDs? And if it's been long enough, I'm going to toggle it from on to off. So for LED 1, how long has it been? It's been the current time minus whenever we toggled it last, and we say, well, if the amount of elapsed time since that last toggle is at least greater than or equal to half of that blink period, then we're going to toggle it. And how do we do that? Well, if it's on, we're going to turn it off, and we're going to keep track of the fact that, okay, now it's false for whether it's on. And in this else clause here, so if LED 1 is not on, well, we're going to turn it on, and we're going to keep track of the fact that we turned it on. And now we're going to update that time when we last toggled it to right now. And we have to do the exact same thing for LED 2. So let's just check and see if this code actually works. So now we're going to define that use this correct version of the code. And we will upload that. And we can see it's uploading. And now, lo and behold, each LED is independently blinking at the correct rate, which is great. So now we've not only written a better program, we've actually written one that works. That's always nice. So So if we look over here again, one of the things that we're going to have to realize really is that we've kind of introduced a whole other problem now, which is every time we've got an LED, we're going to have to keep around this extra state. We're going to have to declare a couple of variables every time, and apparently we're going to have this block of code. Now again, we would turn this into a function that would have to take all of these arguments, the pen number, the blink period, the current elapsed time, or the last elapsed time, whether or not it's on or not. And we're going to have to see how to fix that with our next version of the code. Okay, so now we're going to go to a version that is much better. And that's going to be version 4. And here we're really going to see much better use of C++ and essentially the right way to do this. So really, the big advantage of C++ that we're going to take advantage of is something called classes and object-oriented programming. And this is really going to let us essentially create a package that consists of a set of functions and some variables that could keep track of state, so that we have what's called an object in C++ that really corresponds to a physical object in the real world if we want it to. So in particular, we're basically going to have one object that corresponds to an LED, and we can create more than one if we want to. So you'll see a few things in C++ here that I'll go over. So first of all, in C++, when we're going to create one of these classes that can represent an object, we use this keyword class, and then we can give it whatever name we want. I'm going to call it LED. I'll talk about this namespace a little bit. You don't have to use this. But in case lots of people like to call their class LED, a namespace sort of gives you a way to make it unique. So this thing is going to be AW, and then you'll see later : LED. So that way, if you're including somebody else's LED library, they won't conflict. It's sort of just like if I had named my class something like that. That just happens to look a little bit uglier. Okay. So then in C++, at the beginning of a class, we have this keyword public, which means that the stuff that's following can be used by anyone who's using this class in a program. We'll see that there's going to be a part that we can declare private, which is just the insides of the class that we might need to implement it, but we're not going to let other people use it directly. So we've got this thing called a constructor, which has the same name as the class, and this lets us initialize the object. So for our LEDs, we're going to keep track of the pin number and whether it's on or not. So again, that's part of the state, if you recall, from version 3. We had to have one of these Boolean is on values for each LED. You'll notice that there isn't anything about the last time we toggled it here. We're going to see that we can actually hide that. And then we can have these functions that are inside this class. They're very similar to the functions that you saw before, where we had a function outside of a class and we called it LED underscore turn off or turn on. Well, here we'll just have the functions declared inside the class. They look pretty much the same. I added this one called isOn that lets you tell whether or not the LED is on or not. And there's this extra keyword const. We can sort of ignore that for now, but it means this isn't going to change the object. It's really just asking a question about it. Here I added a convenience function called toggle, which is since this object now knows whether it's on or off, we can just say toggle, and if it's on, it'll call turn off, and if it's off, it'll call turn on. Because of course, when we're blinking, we really just want to toggle. And now this is where we start to see our sort of event-driven programming. We're just going to say start blink, which is really sort of start keeping track of that timer, and we'll pass in the blink period that we used to have to hard code somewhere in our functions. And start blink isn't going to do the actual blinking. We're going to wait to call a check events function, and this is just a generalized name. Really, for this case, it should be like just check timer. But as you'll start to think about these things, there could be lots of other events in the world. If you think about if you were writing a robot, it might be, have I gone as far as I was supposed to? It could be, did my bump sensor just say I ran into something so I should stop? So we'll see how that one gets used. But really, it's the equivalent of what we saw in version 3, where if we go back here, this is really what check events is going to be doing. It's going to look at the current time, and it's going to compare the elapsed time to the blink period, and well, here's that little block of code that's going to get turned into our toggle function. So really, we're writing the exact same functionality, but we're writing it in a clearer and a more reusable way. So let's go back up here. We were looking up here at the declaration of the class, which is just where you say what all the functions will be. And here we have that private keyword, and that means that everything past it is part of the class implementation. So when we're writing the class, we can use these variables. But if somebody is just using one of these LED objects in their program, they can't refer to any of these directly. So basically, we're hiding this implementation. So again, each LED is going to have to keep track of its pin number, whether it's on. Since we're allowing blinking or not, we'll keep track of whether blinking has been enabled. We're going to keep track of that blink period, and we're going to keep track, again, of this state that's the most recent time that we toggled it, although we're actually going to write it a little differently. We're actually going to call this the trigger time, so we're going to set this to be the current time plus half the blink time. So in other words, the trigger time is going to be when we want to do something. So let's just see how this works. So here's that constructor function, and we're just going to, and again, we're taking in the pin number and whether or not the LED is supposed to start off as being on. And so we'll set these variable values to just some reasonable initial state. And then here's that thing that used to be an LED setup. So we're doing that inside the constructor of this object when it's first created. We're going to set its pin to be an output. And depending on whether we said we want it to be on or off, we'll set it to either on or off. So I've also written it so that if we've started blinking, if you call turn on or turn off, it's going to stop blinking, because it would be weird to turn it on and then have it blink again later. So we'll see this function. So stop blink we'll see in a bit. It's basically just going to say, hey, stop checking the timer. It doesn't matter anymore. So otherwise, in turn on, again, we just have that function we saw in the very beginning. We're going to digital write a high value, and we're going to keep track of our state to know that we're on again. Same thing for turn off. We'll make sure blinking is now disabled. We'll write the low value, and we'll say that is on is false. Okay, now we come to our toggle function, which again is pretty trivial, but it just makes it easier to go from on to off or off to on. And now here we come to that start blink function. So I figure as soon as we start blinking, the user probably wants us to switch. So if we're initially off, calling start blink will immediately turn things on. And then what it's going to do is it's going to set up this information we're going to need as to when we need to change state again. So we're going to say, yep, blinking's enabled. We're going to keep track of that blink period that the caller just passed in here. And we're going to set up the trigger time to be this, which is the current time, plus half of the blink period. And then for stop blinking, we're going to leave things in their current state, but we're going to say things are, the blinking's not enabled, and we'll just clear out those other variables. Now here's check events, which again in version 3 you just saw us reading the timer and comparing the time. So we're going to see if our state says that blinking is enabled, because otherwise we just want to ignore this. So if someone called start blink, then we set is blink enabled to true. We're going to get our current time, and we're going to say if the current time is greater than or equal to that trigger time we computed, we're going to toggle. So we're going to make a little copy of the blink period, because as I wrote toggle, it called stop blink and cleared stuff out. So we're going to make sure we put that stuff back in. So again, we've reached our trigger time, so we're going to toggle, and we're going to make sure that now we're ready for the next toggle, which is from now until another half a blink period. And that's it. There's this extra brace that's matching that namespace at the very top. So all the code we've seen now is implementing this LED class. So now we can write the actual program that uses one or more of these LED objects. So here's the entire main sketch, if you will. We still have, for this particular program, we're going to have pins 2 and 3 and these 2 blink periods. Now out here, outside of setup or loop, just out here at what we call file scope, we're going to have a variable whose type is that namespace in LED, so it's AW::LED, and we're going to declare this variable. It's called LED1, and again, those constructor arguments are a pin number and whether we want it to be on at the start, so it's going to be false. So when we put this variable here, this actually goes even before setup, and so it's going to call the constructor for this LED1 object, and it's going to do everything we saw before. It's going to set the pin mode to make it an output. It's going to turn, make sure the LED is off, and same for this one. Now we get to the setup function. Well, we don't have any more setup for the LED objects themselves that we have to do, because those actually happened already in the constructor. But now we do want to start the blinking. And again, remember, this is going to immediately go from off to on, and it's going to set up, keep track of what time we want to toggle again. And now let's look at our loop function, and this entire program is now just LED1 check events and LED2 check events. So really this keeps running forever. Remember, each copy of this function is going to just get the current time and compare it to the trigger time and flip if we've hit that time or not. So this is really the way that we want to write things. And now, if we discover a bug or whatever, we're just going to change it in one place. We don't have to worry about cutting and pasting code. We don't have a set of objects and some variables, a set of functions and some variables for each and every LED in our program. So there's one last thing we're going to want to do here. So right now all of this LED class code is in with our sketch. We're going to take one more step to split this out to where it can really be reused, which is just to split that C++ class out into its own files. So we're going to have what's called a header file. We'll use the class name and a .h. When you write one of these, you can create a new file in a sketch by going here to add tab, and you can create a new file. For any header file, we put what's called an include guard here. In case someone includes this header file, and we'll see what that looks like in the main program more than once, you don't really want all of the header to show up twice. Very weird things happen. So we're just going to have some unique string here, and it's a good idea to use the name of the header file. So again, this says if not defined, that symbol, we're going to define it. And then all of the code goes in here. And at the very bottom, you'll see an end if, which just sort of closes off that block. So basically, the first time you include this file, this hasn't been defined, and we define it, and we get all this code in here. If you include it a second time, it has been defined, so all the rest of this is ignored. Okay, so here we are still in the header file. Now we go to that namespace in the class. Everything we saw before, that's just declaring the class, so none of the function definitions with the real implementation are here. Now we create another file, again, matches the header file, but with a .cpp for C++. If we go to the top, this time we have to include led.h, so this class is including its header. Otherwise, when you try to implement these functions, the compiler will not have any idea what functions you're trying to implement. One other header you need to include when you're writing a separate file like this is arduino.h. Sketches automatically include this, so you don't see it, but all those functions we used, like digital write and the constants low and high, are actually all defined in arduino.h. So here in the implementation, here I've had to stick my namespace here in the class, and after that there's a colon, and again the name of the class. That's the constructor. All this code is the same, except that since this whole code wasn't stuck inside the namespace from the header, I'm having to stick that in here explicitly. And otherwise, this code is exactly the same. And now, if we look at our actual sketch, we can see, again, the program itself is quite small. We're just declaring those objects, starting the blank, check events, that's the whole program. And so if you look at other examples of things more complicated than LEDs, this is the sort of thing you'll usually see because somebody else has written that C++ class for you and stuck it in a library. And so logically, the next thing we're going to want to do is to take led.h and .cpp and put it into a library. We're going to save that for a separate tutorial because there are a few extra steps involved in there. But so I hope what you see from all of this is really the two things. One is the advantage of using classes in C++ so that you can really create an object in your code that corresponds to each of the objects in your Arduino system, which is both a really convenient mental model and a very clean, maintainable, understandable way to write the code. And the other one is just this whole concept of event-driven programming, which is really helpful in the Arduino world because unlike more complicated computer systems, you've really got to do everything yourself. And writing things in the style of event-driven programming lets you write pretty complicated programs without having to spell out every possibility sort of explicitly in the main code and still allow each part of the system to be responsive even when other things are going on. So you can have an LED blinking, you can have your motor turned on and driving you forward, you can have your sensors detecting whether you've bumped into something or whether the light sensor has discovered that it's crossing a line on the floor, and you'll be able to respond to all of those events quite cleanly. So I hope you've enjoyed this, and I'll see you next time.